Hi, my name is Shane Metzger. I'm the Vice President of Sales and Marketing with Airfloat. Today we're going to be talking about skid sets and kind of the components of skid sets, and then getting into a demonstration of how to use your skid sets. So with that, I'm going to jump right into the most important component of your air bearing skid set, which is the air bearing. Our air bearings at Airfloat are constructed of a pliable neoprene or urethane, depending on the application, material, and you can see the convolutions that we form into our air bearings. This air bearing is designed to basically be placed upside down onto the floor, and the air is interjected into the center of the air bearing. Now, how air bearing works is when the air is interjected into the air bearing, it inflates the bellow of the air bearing, making the air bearing completely in contact with the floor around the perimeter. That seals the air bearing to the floor. And once that is done, then the air passes through these communication holes in the center, and the air is forced out around the perimeter, creating a very thin film of air that the air bearing is floating on, basically like a hovercraft, but on a very thin film of air. This creates a virtually friction-free environment to move your load on. The air bearing, as you can see, is attached to what we call an air bearing back. It is basically roll formed onto our air bearing material, and this allows us to mount this air bearing into various applications. For the purposes of an air skid, this air bearing is actually mounted to an air bearing tray. This tray is a removable tray in your skid set so that you can pull the air bearing in and out of the tray while the tray is still under load to inspect the air bearing surface for any signs of wear, or if you might have run across a sharp object and sliced your air bearing. Now, the air bearing tray is nothing more than a formed piece of steel with some tapped holes in it that is mounted into your skid set. And this is a typical arrangement of a steel skid set. And you can see the air bearing tray here. There you can see the air bearing mounted to the tray. And as I described, you can take these two bolts out while the skid is under load and pull that tray out if need be. The general construction of a skid set is obviously the air bearing tray, and then we've got the rest bars of the air bearing skid. These rest bars are what bear the load when the skid set is at rest and there is no air being introduced into the air skid. There's also a couple of tubes which we at Airfloat call hop tubes. These tubes are very critical to the operation of an air skid. It prevents the air bearing skid from hopping under various floor conditions and various load conditions. As you can see, our air bearing skid is set up with an air inlet. This air inlet will be demonstrated further when we get into the operations of how to use your skid set. And there's also a mounting pad. Now, this mounting pad is complete with a couple of tapped holes that you can mount a framework to this skid set and allow it to be used in multiple applications. It's not necessary to mount it to the skid set. As you'll see in the video further on, you can just place your load directly on top of the skid and let it operate in that fashion. We'll get a little more into detail on how much load area footprint needs to be on top of this skid set. Now, there's a couple of different styles of air skids that we at Airfloat have. As I have demonstrated to you here, this one is our standard steel skid. We also have an aluminum skid. This is a cast aluminum skid. This skid is very similar with the air bearing tray that can be unbolted at either end, and the tray can be pulled out. Same air bearing concept on the bottom. The difference being you have a cast aluminum surface with the tapped holes for the mounting area. And the advantage, obviously, to the cast aluminum skid is it's much lighter, easier to use. And as you get into the larger diameter air bearings, this will obviously allow an operator to place a larger air bearing without the assistance of a fork truck or, say, an overhead crane. Next, we'll move on to the requirements for your flooring and your air requirements. We're going to talk a little bit about the flooring requirements when using an air bearing skid set. This is one of the most critical facets of using an air bearing skid set, and I'm going to get into the three main characteristics of your floor that are required for proper utilization of a skid set. That would be the smoothness of the floor, the levelness of the floor, and the flatness of the floor. To further illustrate the latter of the three, the flatness of the floor, I've got a straight edge here, and you can see that from one end of the straight edge to the other end of the straight edge, there are no dips or hills in this floor. That's the flatness of the floor. Airfloat's requirements are for proper air bearing use, you need to have no more than plus or minus a 1/4 inch of undulation over 10 feet of floor length. Likewise, with the levelness of the floor, we recommend that you have no more than a 1/4 inch of variation from one end of 10 foot of the floor to the other. The main reason for this is safety. Since an air bearing is floating on a thin film of air and is virtually friction-free, if you have a declining floor, the load is going to accelerate and pick up speed. And if you have a very steep floor, you could cause a runaway condition, which would have to be then handled by cutting the air to the air bearings and dropping the load back onto the rest bars, as I illustrated earlier. The third characteristic of the floor is the smoothness of the floor. You can see here, this concrete floor is what we call a steel troweled concrete floor, and it is very smooth. Now, some steel troweled concrete floors, especially when they're new, have slight ridges in them, which is basically a result of the trowel passing over the concrete and leaving a thin little edge of mud from the concrete surface. This is not an acceptable concrete floor because those little ridges will basically act like fingernails dragging on the bottom of the air bearing, increasing the friction as you move the load. Other typical examples of smooth concrete floor would be as to compare it to, say, a steel plate. A plate of steel is very smooth and works very well with air bearings. Also, such things as vinyl tile or terrazzo flooring are ideal applications for an air bearing. Now, one of the things that we'll get into in the next segment is what to do with your floor if there are pits, large cracks, and other imperfections in your floor. These can be overcome quite easily, and we will demonstrate some of those things that we can do to basically have the air bearing go over your floor. The last segment that I want to talk about is the air requirements. The general rule of thumb for an air bearing is that you require relatively low pressure but high volumes. Now, low pressure meaning somewhere in the 30 to 40 psi range is what the bearing requires to float depending on your load. We're not needing 90 to 125 psi, which is generally what you would see in a shop environment. However, this higher pressure will allow you to overcome such things as orifices and fittings within your airline and give us the flow that we need at the air bearing. Now, the high flow is going to be determined by two things. One, the condition of your floor, and two, the weight of your load. In the manual that came with your skid set, it will illustrate basic flow requirements for the various sizes of bearings, and if you have any questions, you can further contact Airfloat, and an application engineer will be happy to help you. The next segment we'll be talking about the actual application and operation of a skid and a skid set in your environment.